Welcome, fellow chemists, to a nice and simple introduction to balancing chemical equations. It is kind of a follow-up to the previous video in the sense we are continuing to learn how to properly write equations, and we can still ignore the states of matter. So why exactly must we balance chemical equations anyway? Simply put, reactions follow what is called the law of conservation of mass, which states matter is not gained or lost, so in the equation we cannot gain or lose atoms. Counting atoms, we see sodium once on the left and right, which is good, but chlorine is twice on the left and once on the right. So just get rid of that subscript 2 and we're good now, right? No, because the equation no longer represents the chemistry as we know it. Sodium is involved as individual atoms, but chlorine is diatomic. This means it exists in molecules as a pair of atoms, so that too is very important. Finally, the sodium chloride product is a single substance with that exact formula, so I cannot alter it. While I cannot change the formulas, I am allowed to change how many atoms are present. How? By placing a coefficient in front of the substance or substances that need it. Put a 2 in front of sodium chloride to increase the amount of chlorine from 1 to 2, but it also increases the amount of sodium. Beware, this happens a lot when you balance. An atom that is balanced at the beginning gets thrown off. Don't worry, just remember to go back and fix it. And we can do that by putting a 2 in front of sodium on the left, and we have balanced this equation. That previous equation is about as simple as it gets, but even this one is less complicated than it seems. Accounting for every element on the left, there's 1 calcium, 1 silver, 1 nitrogen, and 3 oxygens. On the right, there's 1 silver, 1 calcium, and what do we do with these parentheses? We treat them like we do in math, except instead of a number on the left distributing in, it's a subscript on the bottom right that does. That makes 2 nitrogens and 6 oxygens on the right. Those values are both twice what we have on the left, and we can see calcium and silver are both equal. With calcium balance, the only option is to put a coefficient in front of silver nitrate. Using a 2 balances nitrogen and oxygen, but it threw off silver. Luckily, it is a simple fix, and adding a 2 in front of silver on the right finishes the job. Combustion equations can sometimes be easy and other times unexpectedly complicated. This is one of the easier ones. The initial account is 3 carbons, 8 hydrogens, and 2 oxygens on the left. On the right, there is 1 carbon and 2 hydrogens, but we find oxygen in 2 places. I account for them by the way they appear in the equation. 2 plus 1 equals 3. Why? Well, to balance carbon, we need to triple it on the right. Put a 3 in front of CO2 and that balances carbon, but the total oxygen is not tripled as the 2 becomes 6, making the total 7. Remember, the coefficient only applies to the substance it is in front of. I have found counting oxygen like this reduces errors, but you may prefer a different method. Now, hydrogen needs to be quadrupled, so put a 4 in front of H2O, and hydrogen is balanced, and oxygen is now 10. This leaves oxygen, and with 10 on the right, the amount on the left needs to be increased 5 times. Put a 5 in front of the O2, and the equation is now balanced. In summary, we balance equations to reflect that mass is conserved, and we start by accounting for all atoms on each side of the equation. When there are parentheses, the subscript on the bottom right gets distributed in. An atom and multiple substances on one side of the equation can be accounted for via addition. We add whole number coefficients in front of formulas to increase the atom counts. Sometimes an element starts off balanced, then becomes unbalanced, then is fixed again by the end. Remember, balancing is a logical process and that expertise will require more practice. But before I put up some practice equations for you to do on your own, thank you very much for watching. The next video will involve more complicated equations, so be sure to subscribe to see when it's uploaded. If you learned from this, please like or leave a comment below letting me know, or to request a future video.